This is example 4.2.2a.3. It says sketch the graphs for time versus displacement, velocity, and acceleration when an object is thrown up. So the first one that I want to start with is the bottom one. And the reason for that is this is the most common problem that people have on tests. If you have acceleration versus time, as soon as that bullet is fired, as soon as that object is thrown up, as soon as that rock is thrown up, it is under the influence of gravity, and acceleration is negative 9.8. Nothing else matters. It doesn't matter that it's going up. It doesn't matter that it's going down. As soon as it is in free fall, negative 9.8. Now, velocity kind of takes its cue from this one. So the slope of this particular graph has got to equal negative 9.8. Because remember, the slope of a velocity versus time graph has to equal negative 9.8. So that should indicate that this line is going to go downwards. But this object is going to start with a positive velocity because you are throwing it up in the air. So if it starts at something like, say, 10, it's going to have a negative slope of negative 9.8 until it reaches negative 10. Assuming that it would hit the ground. I mean, it could be off a building, but this would be the most likely explanation. Okay, so now what we can do is we can look at the position versus time graph. And the position versus time graph, we'll call it y versus t. Initially, this object is going to move up. So remember, the slope of this graph right here is going to equal what this value is here. So really what we can do, and the area is going to equal the area, but really what we can do is we can say that initially the object is going to start at the ground level. And it is going to end at the ground level. But it is going to be under the influence of acceleration, so it must be a curved graph. So what we're going to do is we're going to end up having a curve. It's going to go up. It's going to reach this point right here. And this point right here is the same as this point right here. When it reaches 0, it's going to come back down. When it's going to have the negative velocity term is going to be when it comes back down. And you should have a smooth parabolic curve with equal positive and negative sides. Obviously, I kind of shortened the negative side there, but these are the three sketches of the graphs for an object that's being thrown up.